Alright everyone, let's go ahead and take a look at functions and composition again, because I know we struggled with this a little bit last week, so figured we'll try it out again. So, let's remember what a function is and what function notation looks like. So let's write this function f of x. And if I said f of x is equal to 2x minus 1. Okay. So first, remember that this does not mean f times x. F is the name of the function, and then what does this inside part mean again? Yeah, this is going to be our input. So whatever goes inside the parentheses, that's what we're inputting whenever I refer to this function. So just a quick example, if I were to look at something like f of, let's just say 5. Well, that means that wherever I see my input for x, we're going to put the 5 in its place. So I have 2 times x. I'm going to replace that x, and instead I'm going to put my input of 5. So do we see that? How we replaced my x up here, 2 times x minus 1, with 2 times my input of 5 minus 1. And if I calculate that out, this is just going to be 2 times 5 is 10. 10 minus 1 is going to be 9. Alright, so f of 5 is equal to 9. Alright, well what happens if I decided, okay, I don't want to find f of a number now. If I want to take the composition of two functions, that means I'm going to find f of another function. We're going to substitute another function. So let's make one up really quickly. Let's say my g of x function. So this time the name of the function is g. And let's just call it x squared. Right, so my name of my function is g, and whenever I have an input, I'm just going to take that input and square it to get my output. So now that I have two functions, we can take the composition of them. And let's start off by finding f of, and then in parentheses, g of x. Right, so taking a look at what we have written there, I have f of g of x. What is my input? What is my input? What am I going to replace my x here? What are we going to put in its place based on here? Yeah, so what we have here is just my input is g of x. So in place of that x, we're just going to write g of x. Oops. Right, so let's go ahead and put a g of x is my input. Alright, do you guys see that? My input is g of x, so I inputted g of x. Alright, but if we take a look at this, I want to be able to simplify this and get something nice and clean. Remember that g of x is the same thing as x squared. So wherever I see a g of x function, we can put in x squared in its place, because that's what it is. So let's go ahead and do that. I'm going to have 2 times g of x. Oh, but I don't want to write g of x anymore. Instead, we're just going to take that g of x is equal to x squared and put that in its place. So let's go ahead and grab that and put it in its place. And then we're going to have minus 1. So it's g of x minus 1. Which now if I just simplify this, this is just going to be 2 times x squared minus 1. And there's my answer. Alright, but that was when I took the composition of f of g of x, meaning I'm substituting my g function into my f. But what if we did it the other way around? Alright, let's just draw a little divider here. Split the screen up a little bit. Let's say I wanted to find this time g of f of x. G of f of x. So inside my we have g of f of x. So let me remind you what g of x was first. It was x squared. Right? So now what I'm doing here is I'm referring to my g function, and my input is inside the parentheses. So what am I inputting into my g function? What is inside the parentheses for my g function? Alright, so what we are inputting, yes, is just the f of x. That's what's inside the input. So I know that wherever I see my variable, right, it says x squared up top, g of x is x squared. wherever I see my variable, I don't want to write x squared anymore, right? We want to write in there something to replace that x, something to replace the x. And usually we put it in parentheses. And let's just go and give myself a little bit more space here. Right, so we have f of x is my input into my x squared. So here I'm going to replace that x, right? That used to be an x. We're going to replace it with my input of f of x. Oh, well, let's just go ahead and grab my f of x. Right, there's my f of x. Let's go to replace it in here. Right, do we see what we did there? I looked at my g function, which is x squared, something squared, and then I inputted my f of x function. F of x was over here. I just grabbed that f of x function and replaced it in. Right? So now what do we do? Well, now we just work this out. So what does it mean to have 2x minus 1, the entire thing, squared? Yeah, it just means to multiply it by itself. So this is just going to be 2x minus 1 times 2x minus 1. If we FOIL this out and distribute all the terms, then I'm just going to get 2 times x, or 2x times 2x is going to be 4x squared. 2x times negative 1 is minus 2x. Negative 1 times 2x is minus 2x. And negative 1 times negative 1 is plus 1. And just combining my like terms gives me my answer. Alright. And that's composition of functions. Let's take a look one more time what we did there. Let me write this in again. So for the first one, if I wanted to find f of g of x, it just meant that I took my g of x function as my input. Notice how we replaced the x with my input of g of x and simplified it out. G of x is x squared, so I have an x squared there, which just becomes 2x squared minus 1. If I did it the other way, this just means I'm taking my g function and has an input of f of x. So my input is f of x. I just took my f function, 2x minus 1, and replaced my input with 2x minus 1. If I work that out, it gives me 4x. Oh, I messed up there, didn't I? 4x squared minus 4x plus 1. And there we go.